Hi guys, we are going to take a look at some volume of some different shapes. Remember, the concept of volume is you filling a three-dimensional space. So you think about anytime you fill a cup, or like you have a Kleenex box and you want to think about how much space inside that box is filled with the paper tissues. I often think about potato chip bags. If you guys ever take a look at a potato chip bag, they are not going to measure the amount of chips in there by volume, because if someone drops it and the chips get crushed, there's less space. They're going to be measuring it by weight, because crushed chips and whole chips, they weigh the same. So we're going to be thinking about filling things. Remember that volume is a three-dimensional concept. And that being said, I am going to actually start us on the bottom of our worksheet, and we're going to address cylinders first. And then I think I'll pause and do another video and address the prisms. So let's take a look at the concept of a cylinder. I want you guys to think of a can. If you've ever had a can of corn or a can of beans or a can of soup, what else comes in a can? Those are the things that I think of when I think of canned food. But basically, think of a can, and you're filling from the bottom up to the top that can with whatever you want to fill it with. I'm going to think water. So I'm going to zoom in a bit, because my equipment tends to like that a little bit more. So when we talk about the concept of the volume of a cylinder, again, think can. That is pi r squared. Wait, there's more. Think about why that's pi r squared. Because if we were to take this and stand it on its end, its base, the base is a circle. So we need to figure out the area of this circle, the space of this guy right here, and then say, now how much are we going to fill it? That how much are we going to fill it is what we call the height. And that's the concept of the volume of a cylinder. So when we look at number 8, we've got everything we need to substitute into this formula. I'm going to use 3.14 for pi, but right now I'm just going to write the symbol. Our radius is 2, we're going to square that, and the height, the amount that we're going to fill in there, is 18. And we're literally down to typing. So 3.14. The 2 is the only thing that gets squared, so 3.14 times 2 squared times 18. Guys, we just did the volume. And remember, because it's a three-dimensional concept, we're going to have units, which is centimeters cubed. Would you look at that? Okay, now let's take a look at number 10. Number 10 is a little bit different. On number 10, they've given us the entire diameter, so we need to understand that that radius has to get cut in half, so our radius is 10. The height is 20. We can do the rest of this. Our volume is pi times r squared times height. So our radius is 10, that's going to be the only thing that gets squared, times the height of 20. So 3.14 times 10 squared times 20. We are looking at 6,280 feet cubed. Okay, now this one looks a little bit weird, doesn't it, guys? Well, I think it's trying to tell me that we have a radius of 1. I think that's what it's trying to tell me. I think this one's going to be a bonus, because every once in a while you guys need a challenge. With this particular problem, you guys are going to be tasked with a bonus. If you wish to try this and to figure it out, when you submit your picture for this assignment, on the little comments that you guys should be used to by now, you're going to put in bonus answer number 12 and tell me what you think the volume of that is. That's going to be a fun one for you guys to put. Number 14, definitely we need to take a look at this guy. This one on number 14 has, sorry, I was taking a peek at the other side. I see a figure on the back side. This one is a little bit weird. Notice how it's a cylinder on a slant. So I'm trying to think, I'm not sure what we would slant, but we could. So it's on a slant. If you guys have ever played with a slinky and you slant it, maybe that's how we could think of this. I don't know if you know what slinkies are. I guess maybe that makes me old. But don't stress. This height is the same it's still going to be 5. The height is coming from the center perpendicular to the base. So guys, we're good to go. We're going to have a volume of pi r squared, and I know you're like, wait a minute, it's the radius of the circle, not the extension out, times the height. So 3.14 times 3 squared times 5, we're looking at 141.3 inches cubed. There you go. Quick video. I'm going to create another one for the volume of a prism. I just clicked the wrong thing on my